Hi friends, welcome to my channel. Myself Vignesh Anand. In this video we are going to see about the capacitance and tan delta testing. First of all, the capacitance or tan delta testing, in which the testing is done for checking the healthiness of our insulating material, which is been used in our transformer or CVTs or even insulators, which means the insulating materials for CTs. So normally why we are checking this tan delta and capacitance means the insulator material which is laying between our conducting path and our equipment, in between both the end some insulator will be there. So in order to check the insulator, we are doing this capacitance tan delta mainly during at the time of conduction, which means at the time of current flow. This insulator will carry some of the current, or it will act like an conductive path, which means a minute current flow will be there. So this may cause any factal incident or anything. So in order to check this, we are doing this testing. So mainly, first of all, the capacitance tan delta is used to find the capacitance of an insulation lever, and also the dissipation factor, in which the dielectric dissipation factor, in which the dielectric medium absorbs some energy during the conduction. I have already informed that the insulating material which lays between our conductor and our uh, equipment or material. So in this time, during at the time of conduction, there is a chances of absorption of some of the conductive path in the insulator level. So this dissipation factor, which defines the uh, dielectric medium absorption of some energies. So then the tangent loss is the amount of capacitive voltage and capacitive current at the angle of 90 degree to each other. This is your graph. See the resistive voltage and capacitive voltage, capacitive current and resistive current. This tangent loss, which is 90 degree between the capacitive voltage current and resistive voltage and current. So this is your formula for the tangent loss. Dissipation factor is equal to 1 by Q. Q is our charge. So tan delta is equal to IR, which means current, resistance current divided by capacitive current. So the resistant current, you know that formula, that V divided by R. Then the capacitive current, which is 2 by FCV. This is normally like an Ohm's law. V is equal to IR, where I is equal to V by R. This is your capacitive current formula, which means 1 divided by, normally you know that capacitance is inversely proportional to the current. So we have done the formula, which means we have substituted that formula to here. So in here, that V and V get crossed over and also cancelled. Then remaining 1 divided by 2 pi FCR, where we know that tan delta is inversely proportional to your frequency. That's the thing I have mentioned here. Then dissipation factor. The dissipation factor, or the tangent loss, is the ratio of capacitive component of our current to that of our capacitive current flowing in an insulating material, which means tan delta is equal to IR divided by IC. That's the thing I have written in here. Then this is your commonly known dissipation factor, tangent loss, which generally comes into your capacitance and tan delta measurement for any bushings or transformer windings, CVTs or current transformers, everything. And also this also includes your insulators also. This is our common test which is carried to check the healthiness of our insulator. So there are different types of connections in your tandem testing. First one is your ungrounded specimen test, UST, then grounded specimen test, GST, then another one mode will be there, GSTG, which means grounded specimen test with reference to God. So these three are commonly used tandem measurement. During tandem measurement, we will use this commonly. So first thing is your ungrounded specimen test. This is done for your ungrounded insulator or bushings levels, which means normally CVTs, CTs, then surgisters. This all testing will be carried by a ungrounded testing only. In this testing, there is no grounding path will be there. So you can easily understand that this is used when a specimen is isolated from earth. So which means if the specimen is isolated from the earth, means this testing will be carried out. Just for an example, I have done some wiring. Normally this kit is connected with our one end, two probes. One will be connecting to your primary end and another one will be connecting to your neutral. I just written as like a normal in our transformer how we are doing. I just written as a normal thing. Okay. In fact, if you are going with a CTs or CVTs, means CT primary end and your M point, which means common neutral points will be there in your CT secondary junction box. In there we will connect and we will check this ungrounded specimen test, then grounded specimen test. This calculate the amount of current leakage to your ground, which means the current flowing through your ground path, that leakage will be there. That leakage is calculated by the grounded specimen test. This is your grounded specimen test diagram. You can easily able to understand that the one end of your probe is connected to your primary and another one is connected to your ground with reference to the God is connected to your neutral end. This is your ungrounded, grounded specimen test. So this is your connection for your transformers. An auto transformer, for example, I am saying that for an auto transformer, the connection will be HV plus intermediate voltage to LV. This is your HV, this is your intermediate voltage, this is your 2LV, which means one probe will be connected with the HV and intermediate level, another one will be connected to your LV. Then same connection, HV plus LV to earth, this is IV to earth, which means HV plus intermediate voltage to earth, with reference to earth we will do on another testing. Then next one, LV to earth. This is your auto transformer tandem testing procedure. Then the mode, UST mode, which in here there is no earth lead are connected, so we are using UST. Then GSTG or GST, with reference to God we are doing this testing. Then shunt reactor, for shunt reactor same HV to earth, which is done in GST mode. Then for 3-phase winding transformer, see HV to LV1, HV to LV2, then LV1 to LV2, then HV to ground, LV to ground, LV to ground. This is your common terminals connections, which means these and all the type of connections need to be done. And the testing mode, USD mode, these three are not connected to earth, so we are doing with USD mode. Then HV to earth, LV1 to earth, LV2 to earth, which is done with a GSTG mode. Then for single phase transformer, HV to LV, HV to earth, LV to HV to earth. You can see that HV to LV, in here there is no earth, so we are doing with USD mode. Then HV to earth, GSTG mode, HV. Then next one, HV LV in combination with earth, GSTG mode. This is your common terminologies connections to check the tandem testing in your transformer. So please kindly check my videos before videos. Then In next video we will go with another type of testing in transformers also, and hopefully share your knowledge and gain your knowledge. Thank you everyone. Nandri Vanakkam.